Alright, let's start. This is not any notes, I just want to kind of plant a seed of what we're going to start looking at. Whiteboard. Alright. XY axis. Anyone confused yet? Good. So let's say we have let's say we had like this, y equals x to the third. This basically would look something like this. And you totally have Desmos that you could use to graph it. Let's take a look. Now, things that I want you to realize that we're going to start focusing on. There's something called the derivative. Now, things that have not been told to you mathematically. If you multiply an x and an x together, you go from a linear situation to a quadratic, which means you go from a first dimensional thing to a second dimension. Okay? A derivative is going from a higher dimension to a lower dimension. And a derivative takes place at instantaneous spots. So if I were to take this point right here, if I were to take exactly that point right there on that, and it could be any point that exists on there, I can draw exactly one straight line through that point. Okay? And the thing is, at this exact point, you might have some sort of slope that you could get. And I would say, most of you would say, the slope exactly at that one green point of the black line would be a positive slope. Agree? But then, other things could take place. Let's take another green dot. Let's take a green dot at that local minimum. Okay? So if I were to take the derivative of this function now, or plug in what that value would be, there is exactly one horizontal line that comes in, and this means we have the slope exactly at that point being 0. So the slope of that horizontal black line is 0. And then the third spot that you can see as far as the derivative goes would be, let's say you have a point right here. You have exactly one straight line that'll come through, be tangent to it at this point, and the slope right here will actually be negative. So those are some things that we're going to start looking at. And the thing about derivatives is it becomes a useful tool when you're missing certain informations about a problem. You obviously we have a positive, negative, and a slope of 0. Is it possible to have an undefined slope? Absolutely. Undefined slope is a vertical line. It becomes kind of a trickier thing on a derivative in that situation. But what this basically starts telling us is if I knew this value here, and this value here, if I were to look at those values, I could say, well, this is going to give me a positive, this will be a negative, and this is going to give me a 0, as far as a sine line, a sine line goes. But again, think of a derivative as something as you're reducing the dimensions, okay? I'm not saying that x to the third as it sits on a flat screen is a three-dimensional object, but that just takes place. A few things that take place as far as math goes in a goofy sense. So let's just take something like this. I bet you a nickel at some point in some class, whether it was math, or English, or social studies, you got bored and you drew yourself a 3D looking cube. Agree? So let's talk about the theory of this 3D cube. That looks like a 3D cube, but we're representing it in 2 space. So it's easy to represent what a 3D cube could look like. Some of you might be able to look at that, being to have all the lines as solid lines. So, I don't know if you've ever seen this optical illusion. Some of you might see this front square as projecting out to you. Some of you might see this square as the one projecting out. And it's basically, when you look at this point, is this point into the board or is it out of the board? And I don't know if you've ever seen that type of thing take place where it starts flipping on you going, wait a minute. Okay, so that is a 3D object represented in 2 space. If I were to take this whole 3D object, let's see if I can, nope, that's just going to move it. Let's draw ourselves another 3D object over here. Let's pretend I can draw 2 squares exactly the same. Or let's connect the appropriate vertices to each other. Oops, I should need to connect those. Let's connect our appropriate vertices to each other. This is called something called a hypercube. And a hypercube is a 4D or fourth dimensional representation. Now, I did not change the dimensions of my board. My board is still only 2 dimensions, being it's a flat surface. So here's the weird thing as far as the math starts going. We have an idea of what shapes might look like at a different dimension, but we're not able to fathom it. We can tell what it would look like in a lower dimension that we can convey. As far as what we know right now, a dimension is something that you can go 2 directions in. You can go right, left, up, down, frontwards, backwards. So theoretically, right now, we live in the 3rd dimension because we all have a length, width, and a height. Some people might say, well, what about time? Is it time a dimension? Well, time could be considered a dimension, but we don't know how to go back in time. We can only go forward in time. So theoretically, time is a half dimension. Now, let me ask you this. Could I take some toothpicks or popsicle sticks, connect them all together, and then connect all the appropriate vertices with longer sticks? Could I make that object right there look like a 3-dimensional thing? Meaning, could I take 2 boxes and connect all of the appropriate corners to each other? Could I do that? I mean, it's not the most fun art project, I get it. So if I were to take those 2 boxes, such as my blue boxes, and then I connect all the corners to each other with a piece of string, I then have a representation of a 3-dimensional object which actually lives in the 4th dimension. So basically what you need to think about dimension doing is I can go right, left, I can go up, down, and I can go backwards and forwards, and then my final dimension is I can go backwards and forwards here. Okay, so I can't tell you what that shape looks like in 4D, but I can tell you what the shadow of the object looks like in 3D. And the strange thing, and this kind of took a weird turn because I'm a weird dude. So think about this summer. You're sitting on your front driveway, just hanging out, and you see an ant walking along the ground. So if you stand up and you look down at the ant, in theory, doesn't really react by you looking down at it. When does the ant react? If you have a little ant that's walking, you get your little bug, 6 legs on it. That little ant walking, if that little ant were walking on that board, if it was a real ant that I could draw, do you think me sitting here at this distance looking at that ant is going to make that ant react in any different type of behavior? No. When's that ant going to react? I go put my hand in front of it. Ah! Squished it. It's gone. Okay? If I didn't squish it, that little ant is going to say, oh no, and it's going to change directions. My hand just messed with its dimension. My finger, if I start doing this in front of the ant is going to change direction because I am interfering with it. So think of an ant as a small little item. Yes, they do exist in 3D, but they're really close to the ground. So think of it just on the ground. Again, if you see an ant walking on your driveway, and you're like, oh, look, an ant's walking on the driveway, the ant's going about their day until you get down to their dimension and start messing with it. So, in theory, the ant doesn't even understand that I exist from afar because I'm not bothering it. They ignore me. Okay, does the ant see me? I don't know. I've never talked to an ant. I don't know what their brain pathways are doing if I approach an ant, whether it sees me as something different. But here is a weird type of thing to think about. Multiple dimensions exist. They have up to 11 dimensions that are defined in physics. A lot of the dimensions actually take place at the smaller molecular level or in great space. Okay? So, if I could create myself two blue boxes, two three-dimensional boxes, connected by straws or toothpicks or whatever, and then I connect all their vertices, I have the shadow of that box. Now, if I have a light source, I could shine a light source through my two boxes, and my shadow wouldn't have colors. It would just appear to be a shadowed object of this three-dimensional object. So here's the weird theory about this. If multiple dimensions do exist, and the shadow of a higher dimension is cast in a lower dimension, we get to see that shadow, which means we're all three-dimensional objects. Are we the fourth dimensional shadow of something that exists in a higher dimension, and is we as a shadow?
Your words are confusing.
Oh, yeah. So what do you think? It's kind of a weird thing too. You talk about 11 dimensions. What's at the 12th dimension? Does it exist? 13th dimension exist? It could. We just have things defined. So when I go back to derivatives, derivatives is you're lowering the dimension at an instantaneous spot, and you're figuring out what the slope of the line at that exact spot would be. And that's what we'll start working on a little bit next week. And of course we have spring break coming up. So tomorrow we're going to do real life of buying a car, kind of give you some thought, food for thought of how you would buy a car, how it becomes a good thing. I mean, we all like cars, we all like transportation, we all like our independence in a car. So how are we going to do that? And then Monday, Tuesday, Wednesday, Thursday, we'll work more with derivatives. And then Friday next week has nothing to do with math, but what I always tell, and I'm sorry you guys didn't have me first semester, but for my senior classes I have a Halloween story that I tell right before fall break, and in the spring I always tell the orange story the Friday before spring break. And those are two of the stories that fall into the stupid shit Stirrup did stories. And I will tell you that the orange story, there were laws that were broken. Fortunately, the statute of limitations has run out and they didn't catch me. So it'll be a fun story for you a week from tomorrow. But that's our start on derivatives. So let's